Um, so we're recording. So today is going to be 5.5. Yesterday or last time we did 5.4, multiplying, dividing. Now we're going to do adding and subtracting rational exponents. Now before we even start, I just want to make clear what a rational exponent is. A rational expression. A rational expression is this. Just an expression that's a fraction. That's it. This 3 over x is a rational expression. 2x over 4, let's do 5, is a rational expression. Okay? So it's just a fraction. We're dealing with fractions essentially. So now we're going to add and subtract. So just a reminder, how do we add and subtract fractions? So 2/3 plus 4/5. In order to add and subtract fractions, and this is a normal fraction, we had to make the denominator the same. So how do we do that? We found something called the least common multiple. Sometimes we call it the least common denominator. So we need to find the least common denominator between the two. Now the denominators are 3 and 5. From that situation, the least common denominator is going to be 15. Both numbers go to 15, and it's the smallest number both 3 and 5 goes into. So on the left, I'm going to times both by 5 over 5, because 5 times 3 gives me 15. And on the right, I'm going to times the top and bottom by 3 over 3, because the top and bottom gives me 15. Particularly the bottom gives me 15. So this one on the left is going to become 10 over 15 plus 12 over 15. And it's really important. We want the denominators to match. We cannot add unless, or subtract, unless the denominators match. So what happens? If the denominators match, we put a little check mark right there. The equal check mark. So that means we add or subtract the top. So 10 plus 12 is going to give me 22 over 15. The 15 stays exactly the same. Remember, only the top changed. And keep in mind, that's a little different from multiplication, because in multiplication, we multiply straight through. In here, we're only adding the top part. Okay? So that's a reminder of how we add and subtract fractions. Now, a rational expression is a fraction with some variables. So we got to get through those. So let's say we had, let's do 4 over 3x plus, let's do, I want something I can simplify. Let's do 2 over 3x. The first thing you have to check is the denominator matching? Yeah, they're matching. There's 3x on both of them. After you check they match, you could just do your math. You do the top. 4 plus 2, that becomes 6 over 3x. And then I want to say, is there anything I could do to simplify? Well, both 6 and 3 are simplifiable. So that's 2 over x. And I circle that, and I am done. Okay? So right now, all we did is add and subtract numerators. If anyone has a question, you can unmute yourself. I'm happy to answer. Okay. So all we did is add something. We'll just do a practice real quick of subtracting, and then we'll get to the scheming part, which is, oh, what happens when it doesn't match? Let's just do a quick subtraction. 10 over 6x minus 7 over 6x. Well, the top and the bottom, the bottoms match, so we're good. So then we can subtract the tops. 3 over 6x. I could simplify that to 1 over 2x. So this is your answer here. I did that a little quickly, but it's just subtraction. Just showing that it works the same as addition and subtraction. Okay, so now we're going to get to the scheming, which is when it doesn't match each other. Okay? So what happens when they don't match each other? So let's do 5 over 3x plus 7 over 5y. Okay? So this one's a little strange because now we're dealing with an x and a y. Also, these numbers don't match. So we have to do what we need to do. I'm sorry, we have to find the least common multiple or the least common denominator. So first off, before we find what the least common denominator is, we need to find, is there anything in common between 3x and 5y? 3x is just a 3 and an x. Pretty simple. 5y is just a 5 and a y. Sadly, it doesn't look like anything's in common. Because there is absolutely nothing in common, what I can do is just take this and multiply it over here, and take my 3x and multiply it over here. We want them to match. We want them to be in common. So this guy has a 5y on the right. This guy has a 3x on the left. They share each other, so they're all in common. So what I'm going to do over here.
I don't get it.
Sure. So before, let's maybe finish this problem, and then I'll go back over it. Okay, Jess?
Okay.
All right. So over here, the 5y is unique to the right side. So I don't want it to be unique, though. I want it to be shared or common. So I'm going to give 5y to this. When I say I give 5y, I'm multiplying the top and the bottom by 5y. So this one over here, and let me rewrite it in a different color. The left one is going to become 5y times 5. 5y times 5 is 25y. Over, we have 5y times 3x. When you multiply numbers, you multiply the normal numbers normally. So first we just do 3 times 5. 3 times 5, that is simply 15. Now x and y are different variables. You can't stack them with exponents or anything like that. So because of that, you just write x, y. They just go right next to each other. You can't do anything special with them. Okay? There was a plus sign, so this stays plus sign. Now we're going to multiply the right side by what was unique of the left side. So what was unique about the left side was 3x. So I multiply the top and bottom by 3x. Why? Because I want them to be all in common. I want them to have common ground before they interact with each other. Okay, so let me slide this over a little bit so everyone can see for sure. So 7 times 3x. 7 times 3 go normal. So 7 times 3 is going to be 21. And this is an x, so it's just x. Nobody interacts with the x there. Over here, 5 times 3 is 15. Y times x, there's different letters, so they can't mix and match like that. So it's just xy. And I wanted to point out what's really important is that this now equals this. The left now equals the right. And that's a really good news because once they equal each other, we can add or subtract them. Now the top, we're going to add and subtract, but one is 25y and the other one's 21x. Those are not like terms. Because they're not like terms, we just put them next to each other. We can't combine them. It doesn't become, very important, it does not become 46xy. It's just 25y plus 21x. You can't actually make them any closer like that. You can't simplify that. But they're all over the same denominator, 15xy. We can't simplify it. Remember, the plus sign locks them in together, just like in 5.4. So we can't unlock them by doing like take all y here and a y here. So at that point, we are done. Okay, Jess, there's a lot of things that went on to that question. I want you to try to point out, where do you feel like you got lost? And I'll leave it up here for everyone else if you need to. There was a lot of things that happened on the question. Anyone could unmute and speak up right now. I know in class nobody would hesitate, so don't let Zoom stop you. Ah. Don't let Zoom stop you.
I'm confused why you have to like share the 3x and the 5y to each other.
Good question. Joe, you remember the normal numbers? I need a common denominator.
Yeah.
So this is exactly the same thing. I'm making a common denominator between this one right here, 5y and 3x, and this one over here, 5y and 3x. Now, in this particular example, they had nothing in common to begin with. And because they had nothing in common, I could just multiply all the 3 of x. My next example, I'm going to purposely have something in common and show you how we deal with that, okay?
Okay.
Okay. Any other questions? I'm going to do another example of this. But the reason, half of the reason I want to do this live is just so if anyone has any questions, we can ask them live. Okay. I'm going to flip this over. Hopefully the backside is clean. It is. And let's do another example as I keep dropping my camera. Let's do, and I'm purposely going to pick one that has things in common. So let's do 7 over 10x minus 3 over 15x squared. Ooh, there's a lot of things going on in this one. It looks innocent, but we have to do a little work with it. So 7 over 10x minus 3 over 15x squared. So first off, check the denominators. Are they the same? No, so they're not the same. So now we're going to have to figure out what's in common. So I'm going to write 10x and 15x squared a little separately. I want to, what we're going to say is the factors of 10x. Can anyone unmute themselves and tell me what 10x factors are? Things that multiply to 10x.
5.
5 with?
2.
2. Good. So it's 5 times 2 times x. This right here is the broken up factorization of 10x. 5 times 2 times x. Does anyone want to give a crack on the right side?
Yeah, 3 and 5.
3 and 5. So I'll write 5 and 3. And what about the x's? How's that going to be broken up into?
Times x times x.
Good. X times x. So I broke up the right side too. 15 broke into 5 and 3. And x squared broke into x and x. All right. So remember, my goal is to find the least common multiple. All right. So I want to make them in common. But here's the thing. I want the smallest thing too. I want the least common. So I want the least common multiple. How do I do that? Well, one thing I could do is not include anything that's already in common. So somebody unmute themselves and tell me what's already in common with this one and this one.
5 and 5 and x
They're
and x.
both decimals.
None. These are multiplication symbols, Jess, not decimals.
Okay, back to mute.
But 5 and 5 are in common. Because 5 and 5 are in common, I'm not going to include that when I do the swap between them or I share them.
And 1x.
Good. And a single x. Okay? And a single x. So what's left over here on the left is a 2. And what's left over here is a 3x. So this purpled 2 and 3x was unique about the left and the right. But we don't like them to be unique. So what we're going to do, we're going to multiply the left and the right with what's unique of the other guy. So this left side is going to be multiplied with what's unique on the right side to stop being unique. So I'm going to times the top and the bottom by 3x. And then this guy over here on the right is going to be multiplied with what's unique on the left, which is a 2 over 2. And you make sure you got to be fair to the fraction, so the top and the bottom get it. All right. Let me leave this here. Does anyone want to unmute and try to give me the top? Actually, give me all of the left fraction. Does anyone want to unmute and try to give me?
21.
We could do it.
I heard somebody. Go start it off. Just go.
21.
Never mind.
I heard a 21.
21 over 30x squared.
Good. Almost there, though. 21x over 3 times 10 is just 30. X times x, x squared. Okay?
As I said.
Okay. I'm just making sure.
Okay.
So 21x over 30x squared is your left side. We put a little minus sign, and then need a little space, so I'm gonna have to erase this. But we need a little minus sign. The reason it's a minus sign because this was a minus sign. And what we're going to do is the right side. Now what was unique was 2 and 2. So the top, 2 times 3, I'm just going to handle it, is 6. Over the bottom, 2 times 15x squared is 30x squared. And I'm going to tell you this. If they match, you know you pick the right numbers, okay? If they match, you know the right numbers. If you somehow get a mismatch on the bottoms, then you want to check your uniqueness and see if you could let the right, pick the right unique things. So since the bottoms match, we're free to subtract the top. Usually a check mark goes on the bottom. Let me do that. Now we're free to subtract the top. But 21x and 6 are not even like terms. So it really makes it easy. We can't even do the math. So we're just going to put 21x minus 6 over 30x squared. At that point, we can't take away the x here because it's getting locked in by the minus 6. We can't take out the 3 out of 21 or the 6. It's because they're being locked in by the minus. We put a little box. And we are done. So the hardest part about this section is simply finding what's unique and then multiplying with it. After that, it's usually the addition you can't even do, or the subtraction. So even the addition and subtraction is the easy part. It's just the finding what's unique and figuring out what to do. Would you guys do one more example before we sign off? I see some nods. Okay. Any questions on this one before I erase it? Or if you just want me to keep it up so you can write it for a second. While I look for my Algebra 2 book. So the problem is I clean my room, but when you clean your room, you don't know where anything is. Oh, there it is.
Mr. Tobel? Mr. Tobel,
I hear you. What's up?
do we have any homework?
You
due
will have
tonight?
homework.
No, I'm saying that was due tonight.
I think it happened to be due tomorrow. It should have been due tonight, but we'll make it due tomorrow. I said it was due tomorrow. So.
Okay.
So let's do one more example. I'm trying to pick one from the book. Just want to see what they expect you to do. Okay, that's a decent one. All right. All right, and I think our next class time is Wednesday, but I'd be very doubtful it's Tuesday. So the homework was supposed to be due today.
I think we have you tomorrow
Have
also.
you tomorrow.
We do have tomorrow? Okay.
Yeah.
All right. So I have to figure out, I guess I'll make this today's homework that I've given today. I'll make it due like Wednesday or something. So you don't have two homeworks due the same day, okay?
Are we gonna have more? Are we gonna learn something new tomorrow, or just continue with the homework from today?
I'm either deciding if I'm going to do a day 2 of this. I'm still deciding, so I'll know by tomorrow. I don't know by now. So. Okay. All right. So let's do one more example. Let's do. I'm going to change it a little bit. 3 over 4x minus 1 over 2. Okay. So 3 over 4x minus a half. Okay, so first we just check the denominators. Do they match? No. So now we got to actually, do a problem. So 4x and 2 do not match. So I'm going to write 4x here and 2 over here. And what I'm going to do is find what's in common. I'm going to break down this 4 into its factors. So things that multiply to 4 is 2 times 2 times x. The only thing that multiplies to 2 is 2. So after we figure out the left and the right, we want to cross off. we're going to cross off what's in common. And the only thing in common between these two is a 2. So I'm going to cross that out. So let's see what's unique on the right side. What's unique on the right side is nothing. So what does that mean? That means I'm not going to multiply the left by anything. The left is already minimum perfect as it is. We don't have to change a thing up. We're very happy. The right side, though, we could do some work to it because the left unique stuff is 2x. This is your uniques. I don't know. I need to figure out a better word. Maybe unique is good. I don't know. But 2x is unique on the left side. So we're going to have to multiply it to the right side. So let's bring it over here. Okay. So on top and bottom, I'm going to multiply 2x and 2x. Okay. I'll change my color. The left side stays exactly the same. I'm going to do it over here, actually. The left side stays exactly the same. So it's 3 over 4x. The right side, 1 times 2x is really easy. That's just 2x. And it's a minus sign in here because there's a minus sign over here. The sign never changes for plus or minus in this case. And then the denominator, 2x times 2, or 2 times 2x, is just 4x. These two matches, so we're happy. So now we could subtract straight through. But the thing is, 3 and 2x are not even like terms. So we don't even have to do any adding. 3 minus 2x all over 4x. We can circle it. Very important that 2x is locked in with because it's being subtracted by 3, so you can't simplify the x's in any way. You can't simplify the 2's in any way. Okay? All right. I did record this, so I'll post it on YouTube and Google later. And you could rewatch this lesson anytime. Probably I'm going to go back to video lessons, but I'm going to make mandatory Zoom for some people. Like some people someday, some people the other day. Okay? Otherwise, if you don't have any questions for me, or you want me to stop recording before you ask a question, Just tell me now.
Can you post the homework?
I will post the homework after this lesson. I need to teach the lesson first before I post
Yeah,
it.
yeah, but I meant like I want to do it now. Well, it's in my mind and stuff.
Okay. You want to write it down, or you want me to just post
No,
it?
no, you could post it. I just want you to post it like after
Sure.
this.
Yeah. As soon as this is over, I'll post it. Okay. All right. Any other questions for anybody?
Mr. T,
Yes.
remember, but when you're adding, do you also have to share it?
If you're adding, do you also have to find a common denominator? You're asking?
No, when you find the common denominator, do you have to like switch it like we do with subtracting?
You have to change the common denominator to make a match. If this was a minus or a plus, everything with the common denominator doesn't change. That doesn't change anything. The only thing that changes is what happens on top. So plus or minus is the same.
Oh, but do you share the thingy when you find it?
Say it one more time.
When you add, do you share the thing when you find the common denominator? Do you share it?
Yeah, I use the term sharing. Yeah, you're sharing what's unique. Yeah, you're sharing what's
This
unique
also?
for both of them, minus or addition.
Okay.
The one I did addition for, the first example, they were both completely unique. That's why we didn't have to break it down. It was like 2x and 3y. Because they were completely unique, they shared the whole thing. Here, you're still sharing, but you only share what's unique, which is 2x in this case. Or the other example, that was the plus one, but the other example, I forgot what it was, but 3y.
Okay.
Somebody knows, yeah. Okay, I'm going to stop recording, and then anyone is free to go. You guys, everyone who showed up, got your attendance done?
Thank
Thank
you.
you.
No
Thank
problem.
you,
See you around.
everyone.
See you around, guys. Good to see you guys.